Hello Internet, today I'll be looking at this 1080 Ti from evga. I own this exact card myself and I'm very happy with it. It has an aluminum backplate with ton of thermal pads in between, and it has an aluminum frame under the heatsink, which also has a ton of thermal pads. Overall, I'm very happy with the evga's effort to keep this card cool, but nonetheless it's dead, so let's take it apart and see what's wrong. Looking at the GPU thermal paste, I think this card was dropped so hard that the entire heatsink was twisted. Other than that, I don't see any obvious signs of damage because of all the dirt, so I'll clean it up and show you what I find. Okay, the card is clean. I don't see anything obvious, so let's take some measurements and see if we find anything interesting. Kilo ohms on 12 volt line, 870 on 1.8 volt, almost 80 on PEX, 60 on memory, 1.2K on the 5 volt, kilo ohms on this 12 volt inductor, and this one here. Then I'll measure the V-core in relationship to the 12 volt line. And it's so high I can't even get a reading, so we're good. Switching multimeter to the diode mode, I'll check first pair of the data lines. Third and fourth pin to the right of the notch, expecting to see similar value, and I do. Now same thing on the back, except this time we check the reading after the capacitors, on pin 5 and 6, left of the notch. Reference clock, second and third pin to the left of the notch, I expect to see similar reading on both. PEX reset, first pin on the right from the notch is tested with a negative probe. Okay, everything looks good so far, so let's plug it into the PCI Express tester and verify that the remaining data lines are intact. And it appears that they are. Next, I like to plug it into my power consumption monitor to see how many amps it likes to draw. A hair over 1 amp is a healthy reading. Now I'll plug the card into the riser to take voltage measurements, and the only reason why I'm doing it this way is just so you can see where I take those measurements. If I get 1 volt on PEX, it means we have both memory and V-core. 5 volt and 1.8 volt are also present, as well as all the 12 volt lines, and the GPU is starting to get warm, which is a good sign. To eliminate any variables along the way, I will check the memory and V-core phases with an oscilloscope. All signals are looking good, and at this point there's absolutely no reason not to try to plug it into my test rig and see if it produces a picture. Okay, so I'm not getting a picture, but if you wait a few seconds, the LED on the monitor turns white, and the backlight also turns on, but there's still no image. This is typical for memory-related problems, and I'm already running blind memory tests to see if it generates the report. Opening the report file says that we have a problem with the C0, which is this chip right here. I'll mark this chip with an X of death to avoid any confusion and proceed with replacing it. While I'm waiting for more chips to be delivered from China, to save some time, I will steal one of them from Gigabyte Card. Once chip was installed and the board cooled down, I'll check the resistance one more time, and it looks like we have a short. Taking a closer look reveals that the chip was shifted. possibly because I applied too much flux. Or I should have positioned it more precisely. No big deal. I'll remove the chip again and reball it once more. And if you learned something from this little accident, please tell me what it is. I want to see how many people actually pay attention to what I'm doing here. Side note: as technology gets more and more complex, things get smaller and smaller. As a result, sometimes when I reball these memory chips, balls shift when I lift the stencil, and that forces me to manually align them. This alignment process took me some time, hovering over the chip, staring at it with my magnifying glasses on my face, to a point where my neck started to hurt. But for your entertainment, it only took a few seconds. Okay, the chip goes back on, except this time I spent a little bit more time positioning it correctly, and then I'll solder it once more. One more time I verify that I don't have any abnormal resistances, and it shows 40 ohms, which is a little bit on the low side, but that's only because the card is still warm. Let's plug it in and run another test to see if replacing the chip has helped. Still no image on the screen, so I will run another blind memory test to see if this donor chip was bad. And after looking at the report, it shows me exact same error as before. Okay, let's remove the chip and see what's going on. Using my cheat sheet, I'll be testing all the data lines on the board. Those lines are colored gray and blue, and I will be testing them in diode mode. And what I'm hoping to find is one pad that's not like the rest. This pad is good, this pad is good, this pad is not good. And by not good, I mean there's no voltage drop across the leads, indicating no contact with the GPU. Looking at the board view, the pad that we identified as bad should make contact with the pad under the GPU, but for some reason it doesn't. The easiest ways to attempt to restore the pad connection is to do what is known as reflow. And reflow is basically heating things up, applying flux and bring it up to a melting point. Hopefully GPU will re-establish connection with the board. Once that's done and the card has cooled down, I checked the pad again and reflow did not help, as usual. Next thing to do is to lift the GPU and inspect the pad in question. Make sure it's making connection all the way down to the memory chip. And it looks like it does. Now it's time to test the GPU itself, so I'll clean it up and do some visual inspection. Unfortunately, what we're seeing here is a good number of ripped pads. Somehow I begin to wonder, how hard did this card fall? This explains dried up, nearly burned thermal paste at the top, while the bottom looks okay-ish. This got me so disappointed, I began to blame my cheap preheating station, It's not very powerful and it struggles to bring the board to the desired temperatures, which can sometimes create what's known as a cold lift. But I've done this before without any problems, so it likely isn't the case. With that there, we're gonna have to put an X of death to this GPU, which means this video has come to its end. Hello Internet, today I'll be looking at this 1080 Ti from... So, I stole this GPU from that gigabyte you saw earlier. I don't know if it's alive or dead, so let's find out by taking some measurements. The 4 pads on each corner are ground. I will place negative on the ground and positive on any of the 4 capacitors here. This is 1.8 volt line with 6K. These 4 here are PEX, 237 ohms. That's good. The first one is a frequency generator with 7K. Second one is another PEX, 41 ohms. Memory controller is any of these here at the top, 51 ohms. Little low to be honest, but you never know. This GPU is rather questionable, but I'll give it a try anyway. And I'll also solder the original memory chip back on. I suspect it had nothing wrong with it to begin with. Little bit of flux, little bit of heat, little bit of smoke, and the GPU is on the board. I'll retake all the measurements again, make sure we don't have any shorts like we did after replacing the memory chip for the first time. And it looks like we're okay. I'll recheck the data line connections, card power consumption, as well as all the voltages in key areas, and all is looking promising, so let's plug it in and give it a shot. If all goes well, card should output an image and complain about the external cable. And yes, we have a picture. You guys have no idea how happy I am right now. To illustrate that, let me put this happy face on the screen for you. Okay, so I have to erase this X of death from the memory chip, assuming it still works. I'll remove some of the red pads and replace it with the new ones. Put everything back together, power it up, and run some tests. And as you can see, it had been running for a few minutes by now, showing stable temperatures. But as we already know, test is not complete without running a gaming engine. Or 2. Or 3. Just to make sure we don't get any crashes or lag. And this is it for you guys. Thank you for watching my videos and for all the love in the comment section. I hope you learned something here today, and if so, please give this video a like. And subscribe for more awesome repairs. Goodbye.